Okay, finally, we're going to talk about how to make a battery. Now, I said before, a battery has two elements in it. Usually those are both metals, one that gets oxidized, one that gets reduced. And that's how we can have a transfer of electrons or a flow of electrons and make electricity. Now, how do you know which metal gets oxidized and which gets reduced? Table J will tell you the metal that's higher up will be oxidized. The metal that's lower down will be reduced. Okay, and you'll have a spontaneous reaction if your solid metal is higher than your metal ion. The solid metal is the one that's going to be oxidized. Okay, you may not realize this, but rusting is oxidation. You may have heard the term oxidation to refer to rusting, sometimes in TV commercials or things like that. Anyway, if you have a nice shiny piece of iron or copper, eventually it's going to look like this when it rusts. Rusting is oxidation because those solid iron atoms, okay, and those solid copper atoms turn into iron ions and copper ions that then bond and form other compounds that are these crusty looking cruddy compounds on here, like Fe3O4 or Fe2O3. That's what iron rust is, or copper oxide, CuO or Cu2O3. Okay, rusting is oxidation because atoms turn into ions. They turn into cations. If you've ever seen a car with holes in it from rusting, that happens because the car body is made of all these solid iron atoms, but when they go through oxidation or rusting, they turn into these iron ions, and by giving off electrons, because loss of electrons is oxidation, okay, this is oxidation, these iron ions can just get washed away by the rainwater or salt water or slushy water or whatever it is that is dripping off of your car. So the car body gets smaller because the atoms of iron that make up the car body actually turn into ions and get washed away. That's why you get holes in your car from rusting. Okay, now you already saw this demo where we had electrons being lost and gained by zinc and copper. We had a flow of electrons. Now, if you've worked through the hyperdoc, you've seen diagrams like this where they tell you, okay, this is a Voltaic cell, which is actually a battery. There are two different metals in it. It's just a neatly packaged, a Duracell battery, like I said, is just a neatly packaged version of a Voltaic cell in these beakers. Two different metals, two different solutions, a salt bridge to connect them. Salt bridge is where the ions transfer back and forth, okay? The wire is where the electrons flow, and the voltmeter is just a way to show us, oh yeah, electricity is moving, we've got electricity. Instead of a voltmeter, you could have a light bulb there. You could have some other thing that uses the electricity. Okay, now, one other thing you're going to need to know to help you analyze a battery is Leo says Gur. You're also going to need to know a new mnemonic. That is anox and red cat. Anox and red cat. What do those mean? Well, a battery has something called an anode. That's where oxidation happens. Anox. The anode is where oxidation happens. And a battery has something called a cathode. The cathode is where reduction happens. Red cat. Reduction at the cathode. Okay? So, I'm going to show you a demo. I've made a battery right here. Hey guys, look at this. I made a battery. Here, I've got a piece of zinc and a piece of copper, two different metals with different reactivities. I've got a beaker of zinc sulfate. I've got a beaker of copper sulfate. That's the blue liquid. I've got a salt bridge connecting them. It's just a sponge that's soaked with these two solutions, and that allows ions to flow back and forth. I've got a multimeter that will detect the flow of electricity. Let me unhook this wire. Oh look, the needle is at 0. There's no circuit. When I complete the circuit, hey, we've got electrons moving. One of these metals is losing electrons, one of these metals is gaining electrons. You can't make a battery without redox. Okay, so in that demo, you saw I had my two metals, zinc and copper, a solution of zinc ions and a solution of copper ions. I had my salt bridge so that the ions could travel back and forth, and we were making electricity. Okay, one of these metals was being oxidized, one was being reduced. Let's figure out which was being oxidized and which was reduced so we can describe which is the anode and which is the cathode. Okay, so here we go. Yeah, okay, this is it. So I had my zinc on the left, I had my copper on the right. Okay, in order to figure out which is the anode and which is the cathode, we need table J, and we need to remember anox and red cat. Now, the copper metal was in a solution of copper sulfate, so I had copper ions and copper metal. The zinc metal was in a solution of zinc sulfate, so I had zinc metal and zinc ions. But we still need to use table J to figure out which gets oxidized and which gets reduced. The one that's higher up on table J gets oxidized. So which of these metals is higher on table J? Well, copper's down pretty low. Zinc is up higher. Oh yeah, this is the salt bridge. That is for ions to travel back and forth so we can have a complete circuit. Okay, you can't have a battery without a salt bridge. Okay. All right. Zinc is higher. Zinc is the one that's going to be oxidized. And anox, okay, tells us that the anode is the one that's being oxidized. So zinc is being oxidized, so we call this the anode. This piece of metal is called the anode. That means over here, this piece of metal must be called the cathode because this is where reduction is happening. Okay. Now, the electrons flow this way. Electrons always flow alphabetically. They go from the anode, A, at the beginning of the alphabet, to the cathode, C, further down the alphabet. Electrons like to be alphabetical. If you want to know which is the positive and which is the negative side, the cathode, like cations, the cathode, T looks like a plus sign, the cathode is positive. The anode, anions are negative, okay? The anode is the negative side of there. And again, electrons go alphabetical. So if you want to know which direction the electrons are flowing, they go through the wire from the anode to the cathode. Okay, let's analyze another battery. Okay, we've got another voltaic cell or battery that's made of lead, that's one metal, and copper. Okay, our lead metal is in a probably lead sulfate solution. Copper metal is in a copper sulfate solution. So we got copper and copper ions, lead and lead ions, but we got to figure out which is the anode, which is the cathode, and where are the electrons flowing, just for giggles. Okay, you got to know anox and red cat, and you got to know table J. The higher metal is oxidized. So we got lead, we got copper. Which one is the higher metal? That'll be the one that's oxidized. Just hit pause, look at table J. Okay, lead is higher than copper, so lead is oxidized. And anox tells us that the one that's oxidized is the anode. So we can label this side the anode. This piece of metal is the anode, where oxidation happens. This piece of metal is then the cathode, where reduction happens, because lead is higher than copper on table J. The electrons flow from anode to cathode. They just go alphabetically. That's just kind of a nice extra thing to know. You won't be tested on that. So the lead gets oxidized. Leo says Ger, loss of electrons is oxidation. So this is what the reaction looks like that's happening on the lead side. We're giving off electrons. The electrons are going off through the wire. They're going to the copper side. Hey, so the lead side is giving off electrons. They're going over to the copper side where the copper can use them to go through reduction. The copper ions join up with those electrons, making copper metal. Okay? Just in case you want to know which is positive and which is negative, cathode, okay, the T in the cathode is going to remind you that the cathode is the positive side. Anode or anion, that's the negative side. And remember, electrons go alphabetically. They start at the anode, they end up at the cathode. Let's try analyzing one more. We got a battery made of lithium and magnesium, two metals. Which is the anode and which is the cathode? We need to use table J, anox, and big red cat. So hit pause, figure out which one is higher on table J. Oh, lithium is at the very top. So lithium must be the anode because that's where oxidation happens. The highest metal gets oxidized. So this is the anode. Okay, that means this must be the cathode, and the electrons must be flowing from anode to cathode. And don't forget, the salt bridge in the middle is for transfer of ions. You have to have a complete loop for electricity to be able to flow. And again, the cathode with the T in it, T looks like a plus sign, so that's the positive side. and the electrons go alphabetically through the wire. Just a couple of practice problems. Here we go. What's the purpose of the salt bridge? Salt bridge, salt bridge, salt bridge. It's for ions to travel back and forth, okay? Electrons go through the wire. Ions can travel through the salt bridge. In my demo, I used a sponge for the salt bridge so that mobile ions in solution can go back and forth through that salt bridge, through that sponge salt bridge. All right, one more battery to label. We got a battery made of silver and copper. This is kind of an expensive battery. Okay, well, got to label the anode, cathode, and salt bridge. Okay, which metal is higher up on table J, copper or silver? Copper or silver? Hit pause, look at table J. Okay, Anox and Red Cat and table J are going to help you. That's the salt bridge. Copper is higher on table J, so copper is the anode. Silver is lower on table J. Silver must be the cathode, and the electrons travel from anode to cathode. So there we go. And again, remember, the salt bridge is so ions can travel back and forth. Which half reaction can occur at the anode in a voltaic cell? Okay, at the anode, oxidation can occur. Oxidation is a loss of electrons. So we want to find which of these is a correct half reaction for oxidation. Loss of electrons is oxidation. Right away, we cross off 1 and 2. Those are gaining electrons. The electrons are on the left side, the reactant side. Okay, now we got to figure out, okay, which of these is actually oxidation, is a correct oxidation reaction. We got zinc 0 forming zinc 2 plus ions plus 2 electrons. That looks pretty like a good possibility. This number 4, Fe3 plus, on this side, Fe2 plus plus. Okay, we got plus 2 and we got minus 1. This side overall adds up to plus 1, and this side overall adds up to plus 3. That's incorrectly written. That is not a correct reaction for oxidation. Whereas on this one, we got 0, plus 2, minus 2. Both sides of the reaction add up to 0. That's a correct reaction for oxidation. That will happen at the anode because it's oxidation. It's a correct oxidation reaction. Given the balanced equation representing a reaction in this cell, where is silver produced in the cell? At the anode where oxidation occurs, at the anode where reduction. Okay, right away we can cross off a couple of answers. We know Anox and Red Cat. Anox and Red Cat tells us that at the anode, oxidation happens. So at the anode, we don't have reduction happening. At the cathode, we don't have oxidation happening. Okay, so 2 and 3 are nonsense answers. Let's see, we got to figure out, is silver going through oxidation or reduction? Okay, we got copper 0, and then we got silver plus 1. That nitrate ion overall in here has a minus 1 charge. Then silver 0, copper plus 2, minus 1, minus 1. Okay, let's see. So silver is going from a plus 1 to Ag0. That's a reduction in charge. Okay, reduction happens at the cathode. So the answer to this is it's happening at the cathode where reduction occurs, because going from a plus 1 charge to a 0 charge is a reduction in charge. So that must be happening at the cathode. Okay, that takes us through those practice problems. Thank you for watching.